Quadratic Functions Part 1. Properties of quadratic functions. Let's take a look at functions f of x equals ax squared. The simplest quadratic function is f of x equals x squared. And let's now take a look at the shape of this function. So let's start plotting some points. So when x is 0, y is 0 squared, which is 0. So we can put a point at the origin. X is 1, y is going to be 1 squared, which is 1. When x is 2, y is going to be 2 squared, which is 4. And when x is 3, y is going to be 9. We can also go in the reverse direction, so negative x, we've got minus 1, y is going to be 1. Negative 2, y is going to be 4. And negative 3, y is going to be 9. So you can see that we've got a symmetry happening about the y-axis. So we can join a smooth curve through these points, and what we get is the function f of x squared. What you'll notice is that this shape has a kind of U shape. We call this a parabola. And this parabola has a turning point. So this is the point, its minimum point in this case. And it has an axis of symmetry. So this is the point on the x-axis where the function is reflected. We also have a shape like this, which is an inverted U shape. Still has a turning point, but the turning point is at its maximum and an axis of symmetry. This is f of x equals negative x squared. So the negative term in front of the x tells us that the shape is going to be an upside down U. So in general we have functions of f of x equals ax squared, and these are going to have this form here. We call these shaped U-shaped functions, or a U-shaped parabola. Some people think of it as, because it's a positive coefficient of x squared, that it's going to be a smiley face. And then we got negative ax squared, so we've got a negative coefficient in front of x. We're going to have, it's going to be flipped upside down. We call these inverted U-shapes or lowercase n shaped. And because it's negative, you can think of it as a sad face. So let's take an example. We have a function f of x equals ax squared, and we're given a point on this function with a set of coordinates of 2, 2. We're asked to find the value of a in this function and then state the turning point and the axis of symmetry. So first thing we notice is that this function is U-shaped, it's smiley face shaped, therefore the value of a is going to be positive. It's going to be greater than 0. What we're going to do is f of x is the same as saying y, so y equals ax squared. And now we're going to substitute the coordinates for x and y into this equation and solve for a. So y is 2 and x will be 2. So 2 squared is going to be 4. Therefore 2 is equal to 4a. Rearranging for a is going to be 2 over 4, which is a half. Now we can put this back into the equation. So f of x equals a half x squared. So the turning point, this is going to be at its minimum here, which we can clearly see is at the origin. So this is going to have the coordinates 0, 0. The axis of symmetry, again, is going to be at the turning point, and it's going to be the value of x. So this is going to be x equals 0.